Welcome to qnawire.
Okay. In this problem, we have an electron in an infinite square well. It absorbs a photon with a wavelength of 122 nanometers, and this bumps it in from its ground state n equals 1 to its first excited state n equals 2. We're first asked to, given just this information, we're first asked to find the width of the square well, L. We're then asked to find the what this ground state energy initially was. And finally, we're asked to compare our results to that of the Bohr model for a hydrogen atom to see if the square well is actually a very good model for an electron within an atom. So we compare to Bohr model. So the only equation we really need to use throughout is the equation for energy levels in an infinite square well. It can be expressed various ways using H bars or H's. The way that I find most useful, easiest to calculate, is this one, where it involves the mass of your particle in the square well. It involves Planck's constant and the width of the square well. So let's jump into it and find out. Oh, one more thing. The energy of a photon is related to its wavelength by hc over lambda. Okay. So let's jump into it. So first off, we find the energy of our photon. E is equal to hc over lambda. Plug in Planck's constant, the speed of light, and the lambda that we're given. This will give us an energy of about 1.629 times 10 to the negative 18 joules. So this is a couple of EVs. Set that photon energy equal to the difference between E2 and E1, because we were bumped from the ground state to this first excited state. This will be equal to 2 squared h squared. Oh, one correction. Energy levels are given by n squared h squared 8 ml squared. That's that h needs to be squared. So we have 4h squared over 8 ml squared minus, for n equals 1, just h squared over 8 ml squared, which gives us 3 h squared over 8 ml squared. Solve for L, we get L equal to the square root of 3 h squared over 8 m EP. Plug in our numbers and the mass of an electron. We end up with L equal to approximately 3.33 times 10 to the negative 10. So that's about on the order of an atom. Okay, so that's our first main result. For part B, we're then asked to find the ground state. Once we have L, once we have everything, we can say just E1 is just simply h squared over 8 ml squared. We got L, we got M, we got everything. Plug them in. Get approximately 5.4 times 10 to the negative 19 joules, which is about 3.4 EV. So we got a problem. Comparing this to the Bohr atom, the ground state of a hydrogen atom given by the Bohr equation is, let's say, EB equals negative 13.6 EV, which is definitely not 3.4 EV. So we got an inconsistency. And this inconsistency emerges because the energy levels for particle in a box are proportional to n squared, whereas the energy levels for a Bohr atom are proportional to negative 1 over n squared. So these are fundamentally inconsistent formulas. So for this reason, the particle in a box is not a good model for an atom, for a particle trapped within an atom, at least not an electron. And those are the main results. Thanks.